Let's do a kind of straightforward example here. So here's my problem. I wrote it again so that it was easier to see it, to try to fit it all on the screen. So we're going to have to do all these kind of things here, like finding the roots, which is the same thing as the zeros, even multiplicities, which makes a point of tangency, odd multiplicities, which makes a point of inflection. Even multiplicity, something's repeated, the points of tangency come from the powers, point of tangency come from the powers 2 or great, even powers 2, whatever. I'm messing up how I'm explaining this. Anyway, how about this? Let's start with this stuff down here. Let's start with the left-right behavior. See, the left-right behavior we said was based on the lead coefficient. The lead term. See, the left-right behavior or the end behavior was based on the lead term because we have that chart. We had the chart where we said if my lead term was, like this or this, we referred to the chart to see what our lead term was to decide what our end behavior was. So when I look at something like this, though, I'm going to say, I don't know what the lead term is. It's in factored form. See, this is factored form, so how am I going to figure out the lead term? Well, it's not that hard. The lead term would be if I multiplied this whole thing out. And then somebody yells at me and says, no way, we're not going to multiply that whole thing out. That's crazy. You don't have to multiply the whole thing out. We just have to look at the x's and the exponents. So you can think of it as if I were multiplying this whole thing out, I would have a negative x cubed at some point. I would have negative x cubed times an x squared times an x to the first times an x to the fifth times an x to the sixth. So if I multiplied all this out, I'd get negative x to the 5, 10, 11, 17. Did I do that right? 11, 12, 15, 17. So I'd get negative x to the 17th. And then somebody says, oh yeah, that's an easy shortcut. We would just say, add up all the exponents. And if there's a negative out front, it's going to be negative, right? Now, you got to be careful, though, that the factors, you don't have something like 2 minus x. Because if it was 2 minus x, then you'd have to worry about is it negative or positive based on if it's odd or even powers. But basically, the shortcut, add up those powers if it's negative out front. Oh, negative odd. As we recall, negative odd was up to the left, down to the right. Somebody says, oh man, how'd you remember that? Because ever since I was a little kid, x cubed looks like this. So negative x cubed looks like this, up, down. So if you're up on the left, you're going up on the left, which is going to positive infinity. You're going up. If you're down on the right, you're going down here. So you're going to negative infinity. Okay. So let's look at the easier parts now. The roots are just the zeros. Okay. What makes this go to 0? Oh, 0, x cubed. What makes this go to 0? 2. What makes this go to 0? Negative 4. What makes this go to 0? Negative 7. What makes this go to 0? 6. So those actually end up being my x-intercepts. My zeros are my x-intercepts. So I'm going to be a jerk about this. You're going to have to write these as points. So you would have 0, 0, 2, 0, negative 4, 0, negative 7, 0, and 6, 0. These are all of our x-intercepts. And don't have a cow about this because chances are 1, 2, 3, 4. We're not going to give you problems. 5, 6, 7. We're not going to give you problems with this many zeros to annoy you. 2, 3, 4, 5, 6. So here's our zeros. Okay. Our zeros, which are also make our x-intercepts. The y-intercept is when we put 0 in for the x's and see what happens. Fortunately, when you have this x out here by itself, if you put 0 in there, the whole thing goes, because I know people are like 7 to the 5th, negative 6 to the 6th. These numbers are going to be huge. Yeah, but we put that x by itself out there, so that's just going to turn the whole thing 0 anyway. So our y-intercept turns out to be 0. And as soon as you have an x-intercept that's 0, 0, you know you're going to have a y-intercept of 0. Okay, so we look at this and see, okay, who has the even multiplicities? So x minus 2 was squared, so 2 had an even multiplicity, and 6. 6 is the x minus 6 is to the 6th power, so that's an even. Okay, 0 had a third power. The x by itself, that had an odd. That was third power. The 4, I'm sorry, the negative 4, okay, I just messed up. I hate it when I mess up like this. It's not a multiplicity because it's not repeated. I was just thinking odd. I was just thinking odd. It's not a multiplicity because it's not repeated. But the negative 7 is repeated. So the negative 7 is an odd multiplicity. Even multiplicities, the bounces. So that's your points of tangency. So 2, 0, 6, 0. Odd multiplicities are your points of inflection where you squiggle through. And then somebody says, well, what about the negative 4? You're just going to curve through the negative 4. You don't have to worry about it squiggling. You don't have to show a change in concavity. Now, our graphs are just going to be, fairly inaccurate, but I will be able to look at your basic work and tell if you know the concept. So let me see. We said it goes up on the left. So it's up over here, and then it's down on the right. So we know the graph should be up on the left, down on the right. So these guys are going to connect at some point. So let's see what's happening here. That's negative 7. Negative 7 is a point of inflection. So it's supposed to come down here and then squiggle through the 7. I'm supposed to change concavity when I go through the negative 7. Try to make these as reasonable as possible that I can tell that you actually meant it to change concavity. All right. We don't know yet. We don't know how far down it's going to go yet. That's a calculus problem. That's one of the first big applications of calculus you learn is what happens there. So we're going to turn around at some point. So you do have to show me that it goes down below the axis. So what's happening here at negative 4? Let me see. Negative 4 is the 1 to the first power. So it just kind of curves on through negative 4. It does not change concavity. It just curves on through. But negative 4 had the odd power. We don't know how high it's going to go, so we have to turn back around. Let me see. 0 is an inflection point, which means it's going to squiggle through the 0. It's going to go down. I don't know how far down it goes, but it goes down. Then it's going to turn back around. Let me see what's going to happen at 2. 2 is a point of tangency, so it's going to hit the 2 and then bounce off. We don't know how far down it goes. It's going to turn around. Now we got to hit the 6. It hits the 6, but it's a point of tangency, so it bounces off. And there's our graph. And I know it looks like a slob graph. I agree it is a slob graph. I don't know how far down this one is, how far up this one is, but that's what we're doing. And this is how accurate. When you're in calculus, you're going to learn how to find those maxes and mins. That's, like I said, maxes and mins, you're going to learn how to find those. It's one of your first big things in calculus. Unfortunately, we still got to do this. So when am I above the axis? Well, it looks like I'm above the axis from negative infinity to negative 7, and then from negative 4 to 0, and that's it. That's the only times I'm above the axis. Then I'm below the axis from negative 7 to negative 4, then from 0 to 2, then from 2 to 6, and then from 6 to infinity. So I really have to wait and see the graph before I can answer these questions. There are ways to do this. We could do number lines. If I wanted to do a number line to figure out the answer to all these questions, I could show you all that. But I think for our purposes, it'd just be easier to do this. And like, we're not going to have problems this intense when we get into, our actual problems for grades. But if you wanted to do this by test points, like we've been doing, because this is actually kind of cool to do this by test points. It's like if you tested -2, if you plug -2 in here, it'd be positive. You plug -2 in there, everything would be positive. So, you're above the x-axis over this interval. Then you would know everywhere it's got an odd power, you alternate the signs, because we've talked about that. So 4 had an odd power, so we alternate. -7 had an odd power, so we alternate. 0 had an odd power, so we alternate, so we're negative. But see, then 2 had an even power, so we don't alternate. 6 had an even power, so we don't alternate. So see how we can get the negative, 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 negative. We can get all those negative intervals. So anyway, that's something you could do with if you wanted to. Okay. All right. So this was a problem that was already in factored form. So the next thing we're going to do is a problem that is not factored form.